Welcome to the Fast Mode podcast series. I'm Tara Nil, and with me today is Ishwar Parulkar, Chief Technologist for Telecom and Edge Cloud at Amazon Web Services. Amazon Web Services, AWS, is a leading cloud technologies vendor that helps organizations and individuals build solutions to transform industries, communities, and lives for the better. It boasts the world's most comprehensive and broadly adopted cloud, offering over 200 fully featured services from data centers globally. In his role, Ishwar is responsible for setting AWS technology strategy, defining new cloud services and initiatives to enable telcos to transform to modernized digital service providers. At AWS, Ishwar has worked on cloud innovations such as edge services, building cloud-native telco networks, and applying artificial intelligence and machine learning to enable telco transformation. Ishwar joins us today as part of our exclusive editorial segment on Open RAN. Welcome, Ishwar. Great to have you on today's episode.
Thanks for having me. I'm happy to be here.
Awesome. Okay, so let's start. Where do you see the cloud play a role in Open RAN?
There are a few places where I think the cloud plays a role in Open RAN. Firstly, just in general, we've been looking at the cloud as infrastructure on which you can run network functions or network workloads. So this includes IMS, OSS, VSS, the packet core, and also the RAN, the radio access network stack. So firstly, we look at cloud as an infrastructure on which you can run the ORAN stack. And it comes with the benefits of the cloud. By that, what I mean is total cost of ownership is low because it's a operational model is the cloud model. Then there's security, there's resiliency of the cloud that comes along with it. And there's more importantly agility in terms of building, updating applications as well as building new services and applications. So all of these benefits of the cloud come to ORAN when you run the ORAN stack with the cloud as the underlying infrastructure.
Mm-hmm. Okay, interesting. So expanding on that, how can the cloud help lower the total cost of ownership of Open RAN? You mentioned it just a while ago. So how exactly does that work, and which are the areas where we can see the most cost savings?
So there's different aspects to the total cost of ownership. One is obviously CapEx, which is just your the cost of the infrastructure itself, the servers and the silicon and power required for that. And that's kind of somewhat similar to what you would get in a non-cloud model as well, because the amount of silicon and hardware support you need is kind of the same. The real benefits come in the operational aspects of the cloud or using the cloud to run the radio access network. By that, what I mean is in the cloud, we do deployments 24/7. We upgrade software on the fly without bringing customers down. There's automated monitoring dashboards and measurements and a loop to kind of fix problems built into the overlaying layers that are involved in managing that infrastructure. So all of that leads to less number of resources required to manage the cloud, manage the infrastructure, not just in terms of deployment, but also operational and doing root causes. The other area where the cloud helps is in just optimization of power. So one of the advantages of being on the cloud is it's a multi-tenanted environment, so the utilization of the infrastructure is very high, which results in a lower power. And AWS in particular has focused on Graviton chips, which are very power efficient. So that's another way we in AWS are looking at reducing the total cost of ownership in this space.
Mm-hmm. Well, that's insightful. So how important is xAPP and rAPP ecosystem to the success of ORAN, and how can cloud enable it? Because there's a lot of talk about the SMO and how this has opened up to a lot of new services and use cases enabled by xAPPs and rAPPs, right? So what's your take on this one?
So there's many advantages to ORAN. The fact that it's a plug and play, decomposed architecture of components with well-defined interfaces allows a lot of players to play. But one of the biggest values is the fact that there's a layer on top of the SMO to build these applications, which itself it creates a new ecosystem. So by clearly delineating the layers between the actual radio stack, the SMO, which is your northbound interface, and then xAPPs, rAPPs on top, opens up a whole new ecosystem of players who can now build applications that can optimize the RAN and that can utilize information from the RAN to do other things in applications that run on top. So it's a very critical part, I think, of what the ORAN brings to this space. And the way the cloud plays a role here is, if you look at the cloud, it's a developer platform. It's not just a bunch of servers and storage disks. It's a whole layer of services on top. So we have compute services, we have databases, we have AI and machine learning stacks that run on the cloud. So when you use the cloud as an infrastructure to the RAN, it comes with all of these services that can be used easily by the rAPPs and xAPPs layer to build applications. So it's not just a server that comes as infrastructure. It's actually a piece of the cloud. So it's the hardware, it's the servers, but it's also the services that we run on top. So in the AWS context, we have AWS Bedrock, AWS SageMaker, which are these AWS services that our customers are using to build AI applications. Now, if you use the cloud to run the radio access network, all of this comes with that, which means that you can build xAPPs and rAPPs very easily with these services underlying those applications which are already there as part of that infrastructure. So that's one part. The SMO itself is being designed with interfaces to enable cloud services to orchestrate and resources in the RAN. So that is another way where the cloud can really help manage the resources for the radio stack through the SMO.
Well, great. Pivoting to another popular topic, and you've just mentioned about it, AI, right? So what role do you see AI and analytics playing in Open RAN?
So AI has applications in many areas of the network, but RAN especially is one of the areas that will benefit the most from AI. And the reason is simple. The radio access network deals with a lot of different variables. It's dealing with the environment. It's physics, right? It's not just bits and bytes, but it's really translating radio signals to bits, essentially. So things like efficient beamforming, things like managing power modulation to get better coverage, things like radio planning, so that you can figure out the signal strengths from various points in a geographical area to place base stations at the most optimal locations. All of these type of problems are very well suited for AI because they involve a lot of variables, physical variables, and heuristics and dependencies that are difficult for traditional algorithms to handle. So it's a pretty exciting space for AI ML to apply itself to. And what we are looking at, again, as I mentioned earlier, is through this layer of services that sit on top of the RAN infrastructure that the cloud providers would build to build such applications very easily. So something that took a lot of effort and cobbling of different software components to build now can be done very easily with a few APIs that will come with these services on top.
So with the growing importance of AI in Open RAN and RAN in general, right, that predisposes cloud or increases the value proposition of cloud, because essentially all these AI workloads can be hosted much easily when you have the resources that cloud typically provides. So is that correct?
Exactly, precisely. Is the resources and the services and the capabilities that come with the cloud are all present from day one when you use the cloud for radio access network. So it becomes very easy to build applications. One more point is the fact that most AI applications are not something that just run in one part of the network. Usually they are distributed across. For example, you might want to do training in the cloud in the large regions, but you might want to do inference at the edge. So the cloud is in some way involved anyway. And when you have the infrastructure for the RAN also having the same services, the same APIs as the cloud. You have like a single pane of glass to develop applications which have different modalities across cloud and the edge. So that's the other advantage of using cloud.
Oh, great. Well, lastly, let's talk about some of the challenges in this space, right? One, in the adoption of Open RAN, that's quite a general one. And also, in introducing cloud capabilities to RAN, because this is something new that, once people move to Open RAN, they also have to experiment with cloud capabilities. So what's your take on that? What are the challenges that you see in this space?
So I think one of the challenges is to really see the actual deployments to get the benefits of the cost. Now the architecture has been designed to lower the cost. The fact that there will be multiple players and it will be plug and pay also fits well into the fact that it will be overall lower cost. But we've not seen enough deployments to really vet that hypothesis. So depending on geographical locations, what coverage you want, how you can aggregate the RUs and DUs, up to the higher levels of the stack, that has to play out to really identify what are the best deployment architectures for Open RAN to get the benefits of cost. So to me, that's still an open question, but I think the industry will answer this only when they really start actually deploying them at large scale, these architectures. So to me, that's one of the challenges. The other one is around how compliant all of the ISP vendors are to the ORAN spec, right? So again, I think there is a certification process, but I think there needs to be a little more rigor in terms of ensuring that they are interoperable amongst different vendors.
Wow, brilliant. I guess, those are some of the, major areas that are often talked about when we come to discussing Open RAN and also the use of cloud in Open RAN. So I guess with that, we have come to the end of our podcast. Thank you so much, Ishwar, for joining us today and for sharing all these brilliant insights.
Thank you for having me. It was a pleasure talking to you about this very interesting area.
Okay, great. And to everyone tuning in, thank you for listening. If you guys want to learn more, visit www.amazon.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session. Bye-bye.